You eat a spoonful of ice cream too quickly, and a sudden, sharp pain blooms behind your forehead, nowhere near your mouth, nowhere near the cold object that caused it. This is brain freeze, and despite the name, your brain itself is never actually getting cold. The real explanation involves a rapid chain reaction in the blood vessels at the roof of your mouth and a nerve that also happens to wire directly into the part of your skull where you feel the pain, and some researchers think the entire reflex may exist for a genuinely protective reason. The medical term for brain freeze is sphenopalatine ganglioneuralgia, named for the sphenopalatine ganglion, a cluster of nerve cells located behind the nasal cavity, near the roof of the mouth, that plays a central role in the mechanism. The process begins when something very cold, ice cream, a slushy drink, ice water consumed quickly, comes into direct contact with the roof of the mouth, specifically the palate, an area richly supplied with blood vessels positioned unusually close to the surface and unusually close to the brain compared to most other areas of the mouth and throat. The sudden, significant drop in local temperature at the palate triggers a rapid vascular response. The blood vessels in the palate first constrict sharply, called vasoconstriction, in apparent response to the cold stimulus, and then, once the cold stimulus has been removed or the tissue has adjusted, these same vessels rapidly dilate, expanding significantly beyond their normal resting diameter, called vasodilation, a rebound response that occurs noticeably faster and more dramatically than is typical for most other tissue responses to temperature change elsewhere in the body. Research using ultrasound imaging of the brain's blood vessels during induced brain freeze episodes, including a notable 2012 study led by Jorge Serrador, has documented exactly this pattern occurring specifically in the anterior cerebral artery, a major blood vessel supplying blood to the front portion of the brain, with the artery's rapid dilation correlating closely in timing with the onset of reported brain freeze pain, and the pain subsiding closely in tandem with the artery's return to its normal diameter.